Welcome to the recording for week 4 in Green Design and Technology. You can see that week 4 goes from April 22nd to April 28th. And as always, I have things spread out into different days for the week. As you can see, week 4 is continuation of section 1. So if I scroll down, here's section 1, and last week you did a little bit of section 1. This week we're wrapping up with section 1. So this week, you're watching this recording. You're going to do the Class Connect write-up for week 4, and when you go through the lessons, you'll complete the study questions, and you'll turn those in with the study questions from lessons 1 through 3. So you can see there's the study questions right there. So the topics for this week in lesson 4, we're going to talk about global climate change. Lesson 5, we talk about calculating your impact on the Earth. And finally, you have the study questions you'll do, the quiz, and of course make sure you look at the quiz preview that I post, and then you have the assignment for the week. So that's what you have for week 4. So let's go ahead and let's go look at the Class Connect write-up for week 4. And you can see the Class Connect write-up. So some general questions. So on lesson 4, what is the main topic of lesson 4? These 3 main concepts covered in the lesson, and what was one thing you learned in the lesson that you didn't know before. So that's going to be for lessons 4 and 5. You're going to answer those same questions. So let's go right into the recording, or not the recording, the lesson presentation. And of course I'm going to go down to lesson 4 because I covered lessons 1, 2, and 3 last week. So jumping into lesson 4, all about global climate change. So that's the main topic of, or actually the main topic for this week is what can cause global climate change, the current global warming, and how humans are contributing to it. Now, as you go through this, you'll see certain topics. So what I just mentioned, this part right here, this is what this week is all about. So that's the first answer to the Class Connect write-up questions. And then as you go through it, you'll see different topics. Now this talks about climate, and climate is the average weather in a place. So we could say, like in Grand Junction, the climate in the winter is dry with occasional snow, temperatures from 10 degrees up to 60 degrees. We could call that our climate. Our weather would be what it is on a particular day. On April 4th, it was rainy. That would be the weather. So that's how climate and weather are different. And you see that climate takes into account weather, such as temperature and all of that, and humidity, wind speed. So that's what climate is composed of, all of those things. And what a lot of people think is that climate is the summation, or all the weather added up and then averaged out over a certain time frame. So you could think of that too. And of course, climate changes for the season. So in Grand Junction, our climate during the summer is much different than our climate during the winter. Factors that affect climate, so you can look at this, you can see static factors, things that stay the same, don't change. So I'm talking about Grand Junction or Denver, wherever it is. Well, distance from the equator is static. I mean, in Denver, you're a certain number of miles from the equator, and that's important because of how the sun works. Also in Denver, your altitude is static. It doesn't change. Denver altitude is higher than Grand Junction, so Denver, in general, probably has a little bit colder temperatures. And there's also something called urban heat effect. This is when urban areas like cities have lots of roads, buildings, and such, so they absorb heat. So they can be, if you look down here, it can be 5 to 10 degrees hotter in cities than it is out in the country. So those are static factors, things that never change. Then dynamic factors, these are ones that do change. So of course, cloud cover, different times of day, different times of the year, from day to day. So cloud cover can make a difference because clouds reflect the sun's light and the heat. So if you have clouds, then usually it's cooler. The axis, the Earth rotating on its axis, that you might say that is static, but it's actually dynamic because the Earth is tilted. So the Earth actually Different parts of the earth face the sun or closer or more direct to the sun at certain times of the year. So you can see this picture, like right here, this image, this is during the summertime in the northern hemisphere because the sun is pointing more directly towards the northern hemisphere. Over here, this is summertime in the southern hemisphere because I can see the sun is pointing more directly at South America. And you can see that in the United States, we're above the equator, so this time of year, this would be our winter right here. So the Earth's axis, the tilt of the Earth, is a variable. So you can read this all about weather and seasons, or climate and seasons, the dynamic forces. Now here's some things to check, see how well you did on that, what you learned from the last couple of slides. Global climate change. It's when almost all areas of the Earth change. And the reason all areas change is because we are in a system, a closed system. So if there's a change in one area, then it's going to change somewhere else. Have the opposite effect somewhere else. But climate change isn't new. You can see right here it's happened many times. During the time of the dinosaurs, Earth went through long periods of time when it was much warmer than it is now. And then about 20,000 years ago, the Earth was cold and we had glaciers covering most of the United States. So global climate change isn't nothing new. It isn't anything new, I should say. Different causes of climate change. Solar output, meaning how much sun the energy releases. So you can read through this to learn a little bit more about that. Continental drift, of course. The movement of the Earth's plates. So you can see continental drift down here. And of course, that would not have an immediate change or day-to-day change, but over thousands and thousands, millions of years, it could change climates. Orbital changes. So this would mean that the Earth, in its rotation around the sun, it doesn't do the same thing all the time. It gradually moves either further away from the sun or closer to the sun. I mean, just nothing that's going to change our time, our temperature or climate from one day to the next, but from thousands of years to the next thousands of years, it could have a slight change. And finally, volcanic eruptions and things like that. If you look at this example down here, in 1815, there were several volcanic eruptions around the globe, and it was called the Year Without Winter. So you can go explore 1815 and find out what happened in certain places around the world. Because there wasn't as much sun. Of course, all the crops couldn't grow as usual. People died. There were famines and things like that. So practice. So go through this, see what you've learned. Current global climate change. So this is what you're probably more familiar with. And the Earth's temperature has increased about 1 degree in the past 100 years. And this says, seems like a small increase, but it's really a fast increase when you think about the past in the Earth. If you think about 1,000 years from now, that could be a 10-degree change. Well, that is tremendous. So that could have a huge impact. So some are calling it global warming. So read down through here to learn a little bit more about what global warming is. And some evidence of global climate change. Obviously, we can see that the temperature has changed. Some glaciers are melting. Now, not all are melting, just some glaciers are melting. Sea levels are rising. Well, obviously, if your glaciers are melting, then there's more water flowing into creeks and rivers, ultimately into oceans, so that's going to raise the level of the oceans, right? Then some other evidence is scientists can look at old climate change. They can drill holes through old glacial ice and see what happened years and years ago, and then they can see that what led up to those climate changes conceivably could be happening now. They can also look at rings of trees to see how climates have changed. Practice, so go ahead and see what you know about that. Human contribution. So this is probably the thing that most of you are aware of. I mean, how does mankind affect climate? Well, the first thing to think about is we need to know what greenhouse effect is. And greenhouse effect is where the Earth's atmosphere causes the planet to warm up, and we need to have greenhouse effect. Otherwise, we would freeze to death. So the greenhouse effect is important, but the degree of greenhouse effect is what the issue is. So we have to have greenhouse effect. So the way that all works, the sun's energy comes into the Earth's atmosphere. Some of the energy bounces away, bounces back. So what's not absorbed bounces back. What is absorbed is in the Earth's atmosphere released back down to Earth. And that trapped heat energy is what keeps our Earth warm. Well, so we do need to have the greenhouse effect, but if we get too many things, too much heat coming in, then that's going to be the issue. It'd be just like when you go into your car in the summertime. If you go into your car at 10 o'clock in the morning, it's a little bit warm, but then if you keep the windows rolled up and go into your car at 2 in the afternoon in the summertime, it's a lot hotter, right? That's greenhouse effect. Same thing. So humans add to the greenhouse effect. So you can see, we add to it and cause the warming with carbon dioxide, methane, and nitrous oxide. Those are common greenhouse gases, and we contribute to that. And there are also some natural contributions to it. So how humans do it, carbon dioxide. So you can read about this, and of course carbon dioxide is when we burn fossil fuels, carbon dioxide are released. And then those carbon dioxides, that is what forms greenhouse gases and trap too much heat in our atmosphere. That's where the issue really comes in. Methane occurs naturally. And you can see by cattle and other grazing animals, we know what methane comes from, right? When they break wind, you can see this cow doing that over here. And so we have, a lot more farms and animals and things like that. Manure produces methane gas. Now, wouldn't it be great if we could take that methane gas and use it as fuel for cars? Coal mining releases methane gas. So there are many things that do that. Landfills release methane gas. So if we could control these, and many companies are doing that. A lot of landfills, they have a system where they can capture those greenhouse gases, that methane, and then they use it for fuel because it's gas, it can burn, it's an air gas. Then finally, nitrous oxide. Nitrous oxide is used in our fertilizer, and of course it has runoff, which is bad, but also when it's burned, it's a result of burning fossil fuels. Now the other thing about methane that wasn't mentioned here, I don't think it was mentioned, is that methane also happens naturally. And it happens naturally in places where plants are, the natural breakdown of plants, in bogs and forests and woods and things like that. So it's a naturally occurring substance too. Okay, practice, see what you can answer there. So in summary, here's what we learned in this, and then if I go back to the Class Connect write-up, the Week 4 Class Connect write-up, the main topic, talked about that, 3 main concepts covered in the lesson, what's one thing you learned. So I want you to discuss this, not just say, I learned what methane is. No, I want you to discuss what this is. So please do that right. So again, and actually I'm going to change this to where it says main topics. It's going to be main topics, so that's going to be the 3 or 4 things that are shown right on that first slide. And then the concepts are the things that you see as you go throughout that presentation. So I think you can easily answer all of these. Okay, let's go back to section 1, and now let's look at, we need to go into Lesson 5. Lesson 5, it's the same write-up questions. So now we're going to calculate our impact. So when we think about our impact, that means the effect that you have on the environment. So the topics here, you'll learn about 2 of the environment systems called the water cycle and carbon cycle, and you'll learn about ways that man impacts the earth. So those are the main topics right in there. So calculating your impact, or how do you figure out what impact or what effect you're having on the environment and ecosystem? Well, let's figure this out. And first we're going to learn about the different systems. So of course the water cycle, and you've learned water cycle year after year in school, so you probably know about it. Of course, water gets evaporated, and then condensation. So that's when the water that is evaporated turns into clouds or fog, so you can see that happening. Then of course those clouds or fog, then they rain or snow, some form of precipitation, so that water comes back down to the earth, and it does one of two things. It can infiltrate, meaning it can soak into the soil, into the rocks, so it permeates the soil, and that fills up our groundwater, which is really important, our groundwater and our aquifers. Or if the rain is too much, then it can run off, and that runoff runs into lakes and rivers and ultimately into our oceans. Then the cycle starts again, water is evaporated from our oceans and big lakes, and it all starts over again. So that's the water cycle. So it's important to know how the water cycle works so you can understand your effects on the environment. So go through that practice, see how you can do on those. And the balance of the water cycle. So it has to stay in balance so that we have enough water for personal use, for agriculture use, for manufacturing use, all of the recreational use. So we have to keep it in balance. And as we affect the balance of water, that can affect global warming, and it can also cause droughts. So droughts is where there's not enough precipitation, not enough water in the area. So we impact that by the amount of water that we use. So if you flush your toilet after, throw a Kleenex in it and flush your toilet, you're wasting 3 gallons of water. Imagine if everybody did that 4 or 5 times a day, how much water that would waste. Or if you leave the faucet running when you brush your teeth, let's say 2 times a day, and leave the faucet running, that's probably 4 or 5 gallons wasted when you can only use about a half a gallon at the most. So water is an issue. And then there's what are called footprints. And footprints, this is how much water a person or people pollute or they use. So your water footprint would be how you can measure that. And you can go right here and figure out your water footprint. Go ahead and figure that calculator to see how much water you use compared to other people. So calculating water footprint. So think about some of the things that waste water. Do you use the dishwater or wash by hand? Dishwashers usually use more water than wash by hand if you wash them by hand properly. Showers or baths. Showers use much less water than bath. Also in shower, and this is kind of personal, but when you take a shower, to really conserve water, wet yourself down, soap yourself off, turn the water off, soap yourself down, then turn the water back on and rinse off. That can save half the water that you would normally use. Toilets. Do you have a low flow toilet, or you have the standard old-fashioned toilet that might use 3 gallons of water? How often do you do laundry? What type of machine do you use? How often do you water? Do you wash your car? All these types of things. So look at all of this. Also public transportation. So imagine if you use public transportation all the time, that uses water, but also that would use a little bit less, if you don't have to wash your own car or something. But obviously walking, riding your bike is the best thing. What type of food do you eat? Meat and dairy products means that water has to be used for those animals. But of course, water also has to be used to produce plants. But plants take much less water to produce a pound of food than to produce a pound of meat. So that's things to think about as far as your water use. So go through this practice, see what you've learned. Now you have what's called a carbon footprint. So carbon, of course we know what carbon is. All organisms have carbon in them. Carbon are the building blocks of life. Without carbon there is no life. Carbon, of course, has particles, and carbon dioxide, meaning carbon and oxygen, are all parts of this. So fossil fuels contain a lot of carbon. So for instance, if you're cooking on a barbecue and you have the briquettes you buy at the store, that's a tree or plants that have turned into carbon, essentially. Fossil fuels like gasoline and oil, those are the remains of animals. And actually, oil will be the remains of animals. Coal will be the remains of plants that have essentially fossilized and then turned into more of their carbon being. So then when they get burned, that releases the carbon dioxide into the air. Now the carbon cycle, just like many things, carbon has a cycle that it moves through. So we have carbon in our atmosphere. And of course, plants take in carbon and they excuse me, remove carbon dioxide from the atmosphere. Then through photosynthesis, then they release the carbon dioxide back into the atmosphere. Some of the carbon becomes part of the plant too. Animals, of course, when we eat plants, use the carbon that was once inside the plant. Carbon becomes part of the animal. We breathe out the carbon dioxide, release it back to the atmosphere. Plants and animals die when we compose, or decompose, I should say. Then, of course, we get released, our carbon gets released back into the system. And finally, with water, you can see, carbon is found in water, and then there's the water exchanges carbon back and forth with the atmosphere through evaporation, precipitation, all of that. So the water and the carbon cycle. Now you know a little bit about those, and you need to be aware that those things need to be in balance. So think about this, burning fossil fuels, it's not a part of the natural carbon cycle. So as we do that, we're adding something to that natural cycle that could put it out of equilibrium or make it where it's not equal. Increasing carbon dioxide. Current amount of carbon dioxide in the air is higher than it has been in 650,000 years, scientists think. And a lot of that is because of what man does. Carbon footprint. So we looked at before water footprint. Now you go look at carbon footprint. And this is how much carbon dioxide you are responsible for releasing into the atmosphere. And this says, obviously, it's not an exact measure, it's just a guess, but it does allow you to compare to other people. So go through this climate change calculator and see what your scores are. So calculating carbon footprint, some things to think about. How often do you take public transportation? Which is positive, this is much better than if you drove your own car. So how often do you ride in a car? What miles per gallon does the car get? Traveling by plane and train, that adds to it. How much fuel do you use? How much electricity do you use? All of these things. You use energy-saving appliances. What kind of food do you eat? Because if we eat food that is developed a long way away, then trains and trucks have to transport it. Imagine if we all grew our own food. If we all grew fruits and vegetables, raised 2 cows every year, and a bunch of chickens for eggs and for chicken meat, carbon footprint will be so much smaller. So those are just some things to think about. So some practice, go through the practice. Now we get an overall ecological footprint. So the same thing. How much impact do you have on the ecology? And so this talks about water usage, greenhouse gases produced, and things like that. So you go through this, you can see what it does when you do the ecological footprint. It might say that your ecological footprint is 22 acres. That means that 22 acres of the earth is needed to support your lifestyle. And then it could also come up and say, in order for if everybody lived like you, we would need 4.3 Earths. So you can see, imagine the impact there. Now think about this. If you do ecological footprint and you need 4.3 Earths, how about if somebody in India, who lives on about $100 a year or $500 a year, how many Earths would they take up if everybody lived like them? A lot fewer than you, because they don't drive, they eat just food that they produce themselves probably. All of those types of things. Don't use a lot of electricity. But if you compared yourself here in Colorado to, let's say, let's say Justin Bieber, with all the stuff that he does in his life, his carbon footprint or his ecological footprint is probably much larger than yours because he flies, travels a lot. He probably eats a lot better food than we eat, those types of things. So he has a much greater impact, lives in a bigger house than we live in. So think about those types of impacts. And you can find ecological calculators, footprint calculators online, and which leads us right into this. And here's the activity to figure out your carbon footprint. So you just click on that, answer some questions, choose your location, then you're going to go ahead and choose your you're going to give yourself a figure, so you're going to choose your own gender and all that. That's just for fun. It has nothing to do with the footprint. You click OK, and then you're going to answer these questions about how much food you eat and all of those types of things. And then you'll come up with your carbon footprint answer. So you can see on this one, this sample, this person's data, we'd need 5.4 planets for that person. And you can see how much the footprint breakdown over here. And I'll post my own carbon footprint just to give you an example. So to support this person's lifestyle, you need 24 acres on the earth. So do yours and see how you compare. So in summary, we've covered all of these things. So what you're going to do is go through this lesson, the Class Connect write-ups you'll do, of course the Lesson 4 one we looked at, Lesson 5, you're going to answer those questions. And then the last thing we have is the Career Connection down here. So if I go back to Section 1, I'm going to go to my table of contents, Career Connection. And now here's the Career Connection. This is Jamie Quigg. She talks about her job, Sustainability Coordinator. So if I go back to the Week 4 write-up, you're going to answer these questions about Jamie. Use your own words, do not copy and paste. What is her typical day? What education did she need? Include other important information you read about her. Review her company's website. Tell me what her company does. So that's all we have for the work for this week. But I'm going to go ahead and do my carbon footprint so you can see where I rank. You can compare yourself to mine. So I'll go to the table of content. You might have your parents try their carbon footprint too. See where they are. Or not carbon footprint, but ecological footprint. So I'm going to go ahead and do mine. So here's the calculator, just popped up. Where do I live? I live in the United States. And I encourage you to go ahead and do it for other countries to see what happens. So how many planets? New user, I get started. Okay, I'm going to be just a random male. Okay. So I'm going through the carbon footprint activity. And have your parents do it all. Try to do it for a different country. Into basic. Okay, how often do I eat meat, beef, or lamb? Occasionally once or twice a week. So beef and lamb, I'd say probably once or twice a week. Poultry, once or twice a week. Once or twice a week on fish and pork. And then eggs and dairy, I eat nearly every day. I have an egg for almost every breakfast. Okay. So next step. Okay, fruits and vegetables. How much of the food, so I could do just basic information or I could get detailed down here. So how much of your diet is based on fresh and unpackaged food? I'd say probably right in there. How much of the food you eat is locally grown and produced, less than 200 miles away? I'd have to say almost none of it is less than 200 miles away. Mine almost all comes from the grocery store. Okay, what comes closest to your monthly new clothing, footwear, sporting goods purchases? A lot, a little. I'm at a little. I don't buy very much. What comes closest to household annual new household purchases? Little, a lot. I think I'm probably going to be right down around here. Don't really purchase many things. How often do you buy new household appliances? And of course, you're going to probably put never household appliances, but think about what your family does. How if you buy home entertainment equipment? Well, I get new models, so mine goes up a little bit. I get new models computers, and some of you get new models and gadgets like phones and things, right? So you need to be honest about that. I have to buy new books, magazines, newspapers for your household. Really never. How much paper waste do you recycle? My family recycles pretty well, so I'm going to go right here. We recycle paper, cans, glass, all kinds of things. How much of your plastic waste do you recycle? We recycle probably not 100%, but probably like right around in here. So we're working through all of this. You can see how nice it is, how interactive it is. Which housing best describes your home? We're with running water, so you want to figure out where you live. Electricity, and don't laugh at this, it's obviously probably more than half the people in the world do not have regular electricity to their homes. How many live in your household? 3 people in mine. What is the size of your home? Our house is pretty big. I'm just going to do this general one. How far do you travel by car each week as a driver or passenger? I drive very little. So I'm going to kind of come 1 to 50 miles. Working from home, I don't drive very much. How far do you travel by motorcycle each week? None. Does gas mileage your car usually have? 15 to 30? That's what mine usually is. How often do you drive a car with someone else? Often. How far do you travel public transportation? Oh, I'm ashamed of that. Well, actually, I need to leave that there. How much do I travel on bus each week? None. Train each week? None. Because I think it goes into airplanes. I travel airplanes. How many hours do you fly each year? Oh my gosh, I fly over 100 hours each year. So here we are. Let's see what mine is. Oh, look, I'm embarrassed. 6.1 planets if everybody lived like me. Look over here, my services are the most. That's the airplane thing. So I bet if I went back and I changed that, because look at the energy use is my biggest thing. So if I went back and changed my airplane, that would make a huge difference. So if I can, let's see if I can retake. Click on the area I'd like to change. That's up here. That's the airline travel. Let's see if I even change this down to something like that. See what changes this makes for mine. Look, that changed me all the way down to 4.5. So it's kind of neat you can change these types of things. So you can see mine, give yours a shot, see what kind of results you come up with. What you can do on this, I'm just going to show my results again so you can see how I can change because I flew less. I could save it. If I save it, then I would have to sign up for this. I don't want to save it. I'm going to go ahead and return to the quiz. So I'm right here. But since I have this, I can do Control Print Screen. And I can open up a blank Word document. And then paste it in there. Now I have this, and I can look at my results. All right. So if you hung in there with me to watch this footprint activity, hope you learned something, and I look forward to you submitting the results of your own when you do that. So again, for this week, there's week 4 work. I look forward to that coming in. Now from now on, section 1, which is right here, we took 2 weeks to do that to ease everybody in this. From now on, every section, every week is going to be its own section. So the work is going to step up a little bit. So I look forward to all of your work coming in. Have a great week, everybody. Bye.